Hey, welcome back to Mr. PL. So Precal, this is Unit 6, Topic 1, Lesson number 3, and we're going to be talking about Pascal's Triangle and how it relates to when you do the expanded form of a binomial raised to a power. So it's basically its application for Pascal's Triangle. Starting off with the warm-up, we have here a question about whether or not it's a permutation or a combination. I'll be honest, there's a little subjectivity. It kind of depends on how you interpret the question sometimes. It can be a little bit difficult. So remember, if the order matters, then it's a permutation. If the order doesn't matter, then it's a combination. So a team of 15 basketball players have chosen 3 representatives to attend a debate. We're kind of assuming here that the people are going to speak of the debate not in any order. We're just going to choose 3 random people, and then they'll decide later who speaks first. So the order does not matter in this case. So this is a combination. So this is 15 choices, a combination, you're choosing 3. So 15 choose 3. So you put that in your calculator, 15 choose 3, or you can use the formula that's right over here. So remember, n factorial, so n C of r, so n happens to be 15 factorial over r factorial, which would be 3 factorial, and then 15 minus 3 factorial, like that. So then you can simplify this down, you can solve it. Or you can just use your graphic calculator, that's the easiest way. So let me turn this on, and actually I've already inputted it. So you have to put the 15 in first, then you press your math and you go to the right to probability, and then go down to the one that says NCR, and then put in the 3. And then you'll see that the answer is 455 different ways to choose 3 people. It's a lot of ways. Now keep in mind, if the order matters, it's going to be a lot more possible outcomes, because then it's going to be the same 455 options, but each one of those options can have a different order, so therefore creating more possible outcomes. All right, so the second one, you have to choose 5 runners from a team of 20 to line up in a race. Now, keep in mind, when you line up in a race, you line up in a particular order. So one person's in the first lane, second lane, third lane, fourth lane, and usually, typically, whichever lane you're in will determine like how far the distance is around the track. So the order in this case does matter. Like I said, there's a little bit of subjectivity in these. So it's a permutation of 20 people choose 5. Which basically, permutations are a little bit easier to calculate using this formula, mainly because n factorial over n minus r factorial, all the bottom numbers are all going to cancel each other out. So basically all you're doing is multiplying the top 5 numbers of 20. So 20 times 19 times 18 times 17 times 16. Now you could do it that way, or like I said before, you could put it in your calculator, 20, and then go over to math, then go over to probability, go down to permutation of 5. So it looks like this, and then press enter, and that is a significantly large amount. So 1860480. Looks like that's 1,860,480. Okay, so on to the main bulk of this lesson, which is talking about Pascal's Triangle. So let me just move myself a little bit to the side. So the idea right here, it tells you right here how to make Pascal's Triangle. It's pretty simple. You start with a 1 on top, and then you're always going to add the 2 blocks that happen to be above it. Now this block right here has nothing above it here but a 1, so that's a 1. Same with this one, there's a 1, nothing above it here. So this is a 1 because there's nothing here. And this is also a 1 because there's nothing here, plus 1 is 1. But this one right here, you add the 2 blocks that happen to be above it, so that's going to be a 2. This is going to be a 1, this is going to be a 3, because 1 plus 2 is 3, 2 plus 1 is also 3, and then 1 plus 0 is 0. Now what you're noticing is that it's going to be 1s all the way down the left and the right-hand side. That's going to keep happening because it's always just going to be 1 plus nothing. So really all of these are all going to be 1. 3 plus 1 is 4, this is 6, this is 4. And I'm going to keep going with this pattern. 4 plus 1 is 5, this is 10, this is also 10, this is 5. Now this is 6, 15, 20, 15, 6. Now what you're probably noticing is that it's going to be the same on the left and the right hand side. So it's kind of like it's symmetrical. So this 4 and this 4 and this 1 and this 1 and so forth, it's always going to pretty much be like that. This is 7, 21, 35. This is also going to be 35. This is also going to be 21, and this is also going to be 7. Now, you might be wondering, what's the whole point of this? Well, I'm going to show you that right now. Now, back in when you did Algebra 1, you should have learned how to multiply binomials by each other. This is really the same thing as x plus y times x plus y. Now, back in Algebra 1, you probably learned a process called FOIL, or first, outer, inner, lasts. Basically, you're multiplying everything over here, each of these two terms by each of these two terms. So x times x is x squared, x times y is xy, and then the inner x times y is also xy, or yx, that's the same thing, and then y times y is y squared. Now, that can be cleaned up a little bit because you have one xy here plus another xy, so you get x squared plus 2xy's plus y squared. Okay, so that's from back in Algebra 1. Now, what if it was to the third power? So then it's really x plus y times x plus y times x plus y. Now, we've already know that x plus y times x plus y is this. So we can really change these two into this. So that way we have x plus y times x squared plus 2xy plus y squared. Because like I said, we already did the math to multiply these two binomials, so that's this. I just replaced it. Now it gets a little bit tricky. So now I have to multiply each of these two terms by all three of these terms. So x times x squared is x to the third. And then x times x2y is 2x squared y. And then x times y squared is xy squared. Now, I'm done with that x. I'm going to do the same thing for y. So y times x squared is x squared y. And y times 2xy is 2xy squared. And then y times y squared is y to the third. Now, this can be cleaned up a little bit, I believe. So we have x squared y and x squared y. So we have 2x squared y's here plus another x squared y makes 3s squared y's. And we have an xy squared and an xy squared, so 2 plus 1 more makes 3xy squareds. So once again, I can simplify this down to just x cubed plus 3x squared y plus 3xy squared plus y cubed. So this turns into this. This is the answer. Now, why did I go through all of this? Because I want to, that was a lot of work. I want you to see that there's actually an easier way of doing this. If you look at Pascal's triangle, you'll notice that the coefficient here is 1, since there is no coefficient. And then the coefficient over here for the y squared is also 1. 1, 2, 1 happens to be the numbers in that second row. Now, you're probably wondering why I said second row. Think of the top as the 0th row. This is the first row, second row, third row, fourth row, fifth row, sixth row, seventh row. Because anything to the second power, so it's like 0, 1, 2. So it's actually going to be 3. It's always going to be 1 more than whatever the exponent is. And then you'll notice this is 1, 3, 3, 1. That's not a coincidence. 1, 3, 3, 1 happens to be all the numbers in Pascal's triangle. So you're just, to do cubed, you would just go to the third row, 0, 1, 2, 3. Technically, if you want to think of it this way, look at the fourth row. But that's like the 0th row. So all you have to do is look at that next row. Okay, so it's not switching to the next page. There we go. So you'll take a look at this. So what if I want to find the powers of the fifth row? Now, I need Pascal's. Oh, I can flip back, but you just saw how long it took. Or I could just do it by numbers. So 1 plus 4 makes 5, and then that makes 10, and then that also makes 10, and that makes 5, and that makes 1. So there's my coefficients. So I can start by, I'm going to try to do this an easier way. I'm trying to not do all that work I just did on the last screen. So the answer is going to be, 1's going to be the coefficient of the first term, and then plus 5's going to be coefficient of the second term, and then 10's going to be coefficient of the third term, and then 10's the coefficient of the 1, 2, 3, fourth term, and then 5's going to be the coefficient of the fifth term, and then 1's going to be the coefficient of the sixth term. Now, remember, like I said before, if it's the fifth power, it's always going to have one more term than it is the degree. Now, I probably gave myself way too much space here, but that's fine. So now what you'll notice, you'll see the pattern here with all these. X squared, x, no x's. X cubed, x squared, x, no x's. So you're noticing that the numbers are gradually decreasing. So this is going to be x to the fifth power. And this is going to be x to the fourth power. And this is going to be x to the third power. x to the second power, x to the first power, and x to the 0th power is technically 1. So I don't need to write times 1. I could if I wanted to. So all of this ends up being your solution. Now, 1 ends up being raised to the 0th power, then first power, second power, third power, fourth power, fifth power. So I can put this, so multiply by 1 to the 0th power, which is 1. Anything times 1 is itself. And then 1 to the first power, 1 to the second power, 1 to the third power. Now, notice that I'm not going down. This time I'm going up with this. I went down with this term, and I'm going up with this term. And then it's times 1 to the 4th power, and then 1 to the 5th power. Now, I really didn't need that, and I told you that was the answer before, because 1 to the anything power is 1, and anything times 1 is itself. All right, just enough time to get the last question done. Now, I'm going to do the same steps I just did with that last question, but this time it's x plus y, so I can't just kind of skip this last number because it's not 1 this time. So it's to the 5th power, so that's going to be the exact same coefficients. So 1, 5, 10, 10, 5, and 1. Okay, so the first one is going to be the first term to the 5th power. So this is x to the 5th, this is x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0th is just 1. So I'm not going to write that. Then I'm going to do times y to the 0th. Okay, I guess I shouldn't have written that. Then y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, and y to the 5th. Now, something you probably have noticed is that all of the exponents always add up to 5. This is already 5. This 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is also 5. 1 plus 4 is 5. And this is 5. That should always happen. It should always add up. The sum of the two terms' exponents should always add up to the same thing as the degree. Throw a plus there, and there's your final answer. You cannot add any of these because you can only add things with exactly the same like terms, meaning they have to have the same exponent for the x and the same exponent for the y. This cannot be simplified anymore. This is expanded as far as it possibly can. All right, I'm going to stop it right there, and in the next video, I'm going to show you how to do the binomial theorem. Thanks again for watching. Have a wonderful day.